this video, I'm going to teach you how to play this awesome math game called Game 24, which is a really good game to try and play to explore and practice times tables. So a couple of things. I got this one just for $10 on Amazon. I can provide you with the link, or if you just search for, I call it Game 24, but apparently it's called 24 Game. You can search for it and get one, and it comes with 48 cards that have two sides. And so on one side is just one variation, and then on another side is another variation with different numbers. And there are three levels of difficulty. There are the one dots, the two dots like you see on the box, and then the more challenging ones are the three dots. And if you see this number, this is actually a 9, and the way you'll know the difference is if you see this one does not have a red fill in, it's a 6. And so the object of the game is to try and get the number 24. Always has to be 24, and so it's a good idea to review some factors of 24. And this word factor, it literally means like a piece of the puzzle, a number that you multiply with another number are factors, and factors occur right in a factory. So I'm just using the analogy of a factory. If we have 1 times 24 gives us the product, and the word product means the answer to a multiplication. So if you think about a factory, produces products, right? Factors multiply together to give us products. So factors of 24, and we can create a factor rainbow. 1 times 24, those are factors of 24. 2 times 12, that's another factor pair. 3 times 8 is 24, and 4 times 6 is 24. So what I've created there is just a factor rainbow connecting the factor pairs. 1 times 24, this would be called a factor pair. 2 times 12, 3 times 8, and 4 times 6. So that could be really helpful in order to find numbers that would multiply together to give you 24, or to create 24 using these four numbers. So I'll get this box out of the way so we have room to write. So the numbers we have here are 6, 7, 4, and 7. It doesn't matter which order you use them in. You can use addition, subtraction, multiplication, or division to get to 24. So right away I see the 6 and I see the 4, and I'm like, well, that's great. I can make 24 using 6 times 4. But I have to use the two 7s. So what if I do times 7 divided by 7? Or I could also do 7 divided by 7 is 1. 1 times 24 is 24. So that would be one way to solve that problem. And there can be multiple ways. You don't have to do it just one way. So then you flip the card over and you're going to see another problem. So this one uses 4, 1, 4, and 2. And again, I can see that, oh, here I can make a 6. I already have a 4. If I can make a 6 using 4 plus 2, so here I'm going to go 4 times 1 is 4, times 4 plus 2, which is 6. And 4 times 6 is 24. I had to group that in order to add those first. Okay, so let's try maybe a more difficult one. You can see that those problems can be fairly straightforward, and maybe we try a more difficult one here. And I might even be stumped for a little while on this one, but actually I think I've seen this one before. I love this single digit. By the way, they do have double digit, integer, fraction, exponent versions that are more advanced. So I want to get to 24. I don't have any factors of 24. I could create a 4 here, but 5 and 7 add together to give us 12. So 12 times 2 would be 24, but I have to use the other 2 as well. So I just happen to know this one. I came up with it right away. 7 times 2 equals 14. And 5 times the second 2 gives me 10, and 14 plus 10 equals 24. So if you were going to write that whole mathematical expression out, you could have 7 times 2 and then plus 5 times 2. And actually, if you know order of operations, you might realize that I don't have to put those parentheses since I'm doing the multiplication and then the addition. Let's see if I can try one more. So I'll give you a minute to think about it as well, because I'm actually thinking about it as well. So, and again, because I've had a lot of practice with these, I've seen a lot of them before, so I know that I already know the answer to this one. And the way I figured it out is I did 8 times 5 is 40, and then I'm going to actually subtract 8 times 2, because that's 16. 40 minus 16 is 24. So I did 8 times 2, 16, 8 times 5, 40, and then subtract the 2 to get 24. And that's basically how you play the game 24.